Welcome to the last session of the day. Do you have any more brain power neurotransmitters left to listen to me for an hour? My name is Billy Hollis, for those of you who don't know me, and I learned to write code in 1973. Would you care to guess what my first code editor was? It was punched cards. And so I did decades of primarily development, but in the 1980s, I started getting interested in UX design as well, and read some books on the subject and really applied it, and that has become more important over the years, hasn't it? So I started learning about design based on my long-term interest in science. I actually went to medical school before deciding what I wanted to do. So I have a lot of science under my belt, and that has proven to be surprisingly helpful in understanding design, because we learned when I was in my programs about how the eyes and the brain work, and that applies directly to design. And that's important for folks like you, because traditional designers tend to take an intuitive approach to design. They work with something until it feels right to them. But see, I know developers, that touchy-feely stuff doesn't go very far with you. You need reasons for things, and very often those reasons are in fact based in science. Typically the science of the eyes and the brain, and pretty much everything we do, everything we experience is tied into how we see and how we think. And that includes, of course, the devices and software that we use. Now, these factors have been investigated for a long time, many decades. I learned 40, 50 years ago about some of these things, and the research has continued. In fact, some of the research I'll talk about today was done 100 years ago by German scientists. So we've got a big reservoir of that. There are a lot of studies, and I could reference those, but honestly, that would be pretty boring. So instead, I talk about the science of vision and cognition via demonstration. In many cases, sort of exposing your own brains and visual system to something so that you can see how it works without the boring detail of studies. Now, it's possible, most of you probably did this, you know that there's some science there because you did things like the blind spot experiment. Did you do that in science class in school? Most of us did. That doesn't really apply much to software, though, because you have to really work to realize the blind spot. The blind spot is the part of the retina where the optic nerve comes in, and there's a little area there where there's no sensation, there's no vision. But then there are things that are kind of common sense that we know about. For example, our visual system is tuned to filter out clutter. If I show you a picture of seashells, you don't really perceive that as individual seashells. It's just a generic field of clutter. And that certainly has application to some of the things in software. But in general, those are obvious, but there are some scientific things that affect how people see that are counterintuitive. Let me show you one. You see this? You see that bar in the middle there? That's actually all the same color. It looks darker to one side, to the right side. You perceive it that way, but in fact, that's not really what's going on. Let's see if I can bring this up and get it over there. I have some demonstration programs for a lot of this. So I've got this in gray and in blue. Let's do it in blue. It's basically the same general effect. So I've got this, you see this right here? This is a blue square, and I can drag it around. But it matches wherever I drag it. Now, you believe that I'm not changing the color as I move it back and forth, right? So the lesson from that is that color is perceived in relation to colors around it. There's actually a very famous optical illusion around that. Let's bring that up next. Some of you may have seen this one. This one has been on the web a long time. You seen that one? For those of you who haven't seen it, the square with an A in it is the same background color as the square with a B in it. But your eyes are not seeing it that way. Your eyes take into account light and shadow and things like that. So that, and we can prove this because I can go and, where's my little, come here. Oh, my mouse is giving me a little trouble. Are you ready now? My mouse has been acting silly. I guess I'll use my touchpad. See if we can get down here. And come on, I need to make you bigger. All right, then I'll just make you as big as it's possible to be. My system seems to be hanging, and I don't know. Oh, there we go. Where's my square? I'm getting really odd results. Let's start this over again. And I still don't see it. I have a little draggable thing, but it's not showing. And you know, I've done this demo 100 times, and I don't understand why it decided not to show that. So, because I've got a draggable thing the same way I do for the blue thing, and I don't really get it, why that's. Let's see if I can get it over here to work. It's just not there, and I don't know why. So you'll have to take my word for it that in fact, when you do that optical illusion there, that those two squares are in fact the same color, and that comes kind of from evolutionary reasons, where you need to be able to recognize threats, whether or not those threats are in the light or in the shadow. So your eyes automatically adjust. Now this has certain implications for design and user interfaces. For example, you don't really need very bright colors for the visual system to sense them. One of the common mistakes that developers make when they develop UIs where they start applying color for the first time is they make the colors far too bright. They don't need to be bright for people to pick them up. And bright colors set off some alarm circuits in many cases in the brain, so they stress people. So you don't want to use bright colors for a lot of your signaling. So all these things about the visual system are there for some good reasons. Our ancestors needed, as I said, to recognize a threat in sunlight or shadow, and because of some of the clutter elements in the environment, we tune out things that we sense are not important right now, and the visual system emphasizes things that it considers to be important, threats in particular. And notice the bright colors there. Bright colors tend to indicate threats. That's why we don't want to use them continuously, because they tend to stress the user. We have pretty good color vision, and it's pretty subtle because as omnivores, fruit being a big part of our diet, then we needed that vision, our ancestors have in the past, to be able to tell when a fruit was ready to consume. You eat fruit that's too green, it makes you sick. And if it's too ripe, then it might also make you sick. So we evolved some of that color vision in order to work to be able to consume fruit, whereas predators tend not to have great color vision. They tend to have vision that's more based on motion. So that's why we don't want to use bright colors too much, and we can do subtle things. So that kind of understanding of the science is the foundation of giving people good interfaces. If you don't understand some of the principles of how people are seeing things, then you're just kind of fumbling in the dark. You've got A/B testing. Well, yeah, but why did people pick A over B? If you understood something about how they were seeing it, you might not have tried B in the first place. You might have realized that A was better and tried a variation that was a C choice that was even better. So you'll get better designs faster if you understand what's going on with the visual system. So we've already seen, because of the way we see color, keep themes neutral, and when you use colors to signal, don't make them too bright. So this is an application that my team wrote in 2008, when some of these new technologies to do very nice visuals were just coming online. And notice that the overall color theme there is pretty neutral. And that allows things like the sticky notes to stand out very, very easily. And even the sticky notes, though, have a reasonably subtle color. They aren't bright yellow. You wouldn't want to do that. And this looks kind of stale to me now, but in 2008, it looked very good, but more importantly, users liked it. I continued to get feedback regularly from people. The English phrase that they would use is, "That's easy on the eyes." I'm not sure if you have kind of a similar phrase or if that translates well, but I heard that over and over again. And color can be useful, as I said, for signaling. It doesn't have to be too bright. In this case, this is a contacts list, and the user is interested in how long it has been since they have talked to these contacts. Well, we've got days and months and years there, but we color months a fairly subtle yellow and years a fairly subtle red to indicate that that might be potentially of more concern than if it's just been a few days that we've seen them. And that illustrates a general principle. You want to present data to the user to minimize cognitive effort in the way that they would like to see it. If they're interested in how long it's been, that's a time span. They're not really interested in the date of the last contact most of the time. But that's what's in the database. So a naive developer might just stick the date up there. And now you are overtaxing the cognitive system. And they go, oh, I saw them in February 9th. Well, let's see, March, April, May. You're doing arithmetic in your head, and that is not really what computers are a lot better at that than you are. So reducing cognitive effort is one of your goals as you design user interfaces. I'm going to revisit this screen a bit later. But not everybody kind of gets it. This is a drugstore app for an American drugstore chain named CVS. And they're my drugstore. They're just way too bright. And they've recently changed this. I shot this screenshot last year. But they're still brighter than they should be. Somebody there said, our corporate colors are bright red, so you have to inject that into the app. Well, I guess branding people really love to spray their colors around, but I don't like it, and I think a lot of other users don't like it either. They don't realize, I think, the side effects of what they're doing by putting those bright colors into their app because they don't understand the science of how people are seeing it. The biggest disaster that did things like that was Windows 8, which was just waving a flag, basically. Look at me. I'm cool. I'm colorful. And that was just, and the people at Microsoft did not get this basic science and didn't realize that putting all those bright colors, and as we will see later, sharp edges, putting all those things in there didn't really work well with user brains. Now, there were plenty of reasons why Windows 8 failed, but those subtle, unconscious reasons that people felt when they saw the screens, that was one of the big reasons why it failed, is it didn't feel good to people. Those sharp edges, I mean, edgy, well, Microsoft was trying to attract attention and look different from the iPad, but that doesn't mean it was a good idea. And I told them that in the beta period, and they just waved me aside. No, Billy, you don't understand. We've done our focus groups. Everything is going to be fine. Well, we found out about that within a few months, didn't we? When the president of your company gets fired over a disaster like that, you can call it a disaster. Now, in addition to color, our visual system is also optimized for seeing and interpreting shapes. And that, I find, is an underused capability in software, mostly because it's a lot easier to do it with today's platforms than it was, let's say 15 years ago. So, for example, here's a status indicator for one of the applications I worked on for cattle management. We had to indicate whether a cow was alive or dead. Well, we could have just put a checkbox there, or the words alive or dead. But it turns out that the fastest way to get that into someone's brain through the visual system is to have an evocative shape that symbolizes that status very clearly. And interestingly enough, because I teach classes to my clients before we begin designing systems, interestingly enough, the idea of turning the cow upside down came from a developer on the design team. That idea did not come from me. Going back to that screen we saw a few minutes ago, notice its use of shapes. I wrote this to sort of indicate some possibilities to a client, about 12 years ago, just to kind of break them loose from conventional thinking. And the smiley face, for example, or the frowns, if they're not happy, that comes out of the science that we have a special portion of our brain for recognizing facial expressions. Did you know that? We are optimized for that. Therefore, if we put that kind of minimalist face into an application, the time it takes for a user to see that and interpret it and understand, they're not happy, but they're pretty happy, that is a very minimal amount of time. The smiles and the frowns are actually reflecting a number. I've got the demo app. Any of you can have it if you'd like it. If you hover over the frown or smile, you'll see a number between negative 100 and positive 100. Does this one have? No, it doesn't have anybody with that. If it gets really negative, some angry eyebrows appear to really let you know that one's really upset. And shapes, notice that they're fairly minimalist. We can layer shapes on top of one another. There's the universal symbol there for a physician to indicate that contact is a physician. And the visual system is tuned to sort that out, because in the real world, things do overlap. And we come from fish who are underwater. There's translucency and transparency in the water. Our visual systems are able to interpret that very well. So using translucency and overlays and things like that is a good way to leverage the power of the visual system. In addition to that, we can stay pretty simple and minimalist because the visual system is tuned to fill in gaps. We don't need to have to see the whole leopard to know that it's a threat. We only need to see part of it, and our visual system will fill in the rest. And as a result, the shapes that you use can be very simple. That's why we tend to have minimalist icons. The designers kind of figured that out through experimentation. The icons do need to be evocative and understandable, and that leads to a problem that you do have to watch. I don't know how much longer the camera icon is going to work, because nobody uses cameras anymore. They all use their phone. And then you've got icons. If you notice on the right side of the screen there, the other income section has what I consider to be a very evocative icon for other income. Do most of you recognize the reference there? Yeah, you see it instantly and it makes sense. What would be another possible icon for other income? I can't think of one that's any better than that. So it's very, very simple. There's not really much to it, and yet your visual system hooks that in your brain to a character on a TV show. For those of you who are wondering what I'm babbling about, the TV show is Breaking Bad, and the main character is a drug dealer. That's the way he makes his income. And that's kind of what he looks like. Now, shapes are powerful for the visual system. Even if they don't have precise meanings, the meanings can be learned, because the visual system just knows how to pick them up very, very quickly. So imagine that we've got an application where there are trucks going out of a facility, and each truck has loads from multiple locations. So the first one there might have 4 loads for different locations, and the next one has 5, I think, doesn't it? Yes. So a triangle might represent a warehouse, and a circle is an office building or something like that. So there are different shapes for different things, and you have to learn it. And in that particular application, there's a hover, so first-time users will understand the meaning of that. But that's basically a parent-child relationship there. We have one truck and many loads. Here, I'll actually show you the working version of that software to get a little better idea. All right. There it is. Hang on. I'll get it over there. There we go. Okay, so you can, and I randomize the data every time. So if I put that up there, we already kind of know the circles and the triangles, and I've got the hover there. And if I hover over something, you'll see something about what that is. Right? Did I get in there? Come on, get in there. My touchpad's not that. There we go. So we've got hover, and we've also got the ability to expand. But what that allows the user to do is very quickly scan that left-hand column in order to find out some essential information about the loads that are on any individual truck. In particular, something about whether they're going to be delivered on time. Which of these trucks do you think have some loads that look like they're at risk of being late? The red ones. Say, and how did you know? I didn't train you. How did you know? Well, that's just intuitive, that the color signals that there's a potential problem. So as you scan down, you can look at a shape and realize, oh, that represents a potential late problem for that load, and it's going to a warehouse or a dock or whatever. And then the app has built in the capability for, if I want to know more about those particular loads, then I can get down and get more detail. And I can even, it turns out there's yet another layer. If you click on a load, it brings up the map for where that load is and such. So that's a design principle that's called progressive disclosure. And it's not really in the visual family, so I'm not going to talk any more about that today. I'm having a hard time getting my cursor to behave. I should have rebooted my system, I think. I'm not sure, but I think the problem might be, honestly, where's my cursor? Oh, there it is. It's not wanting to come over. I think the problem might be, I can see right here, Windows wants to update. And I didn't do that. You can't see it. It's on this monitor, but Windows wants to update, and that's, I think, giving me some grief. This is Windows 11. I can tell you many design flaws in Windows 11. And I'm very disappointed that Microsoft didn't learn some lessons from their earlier mistakes. So users pick up what's going on with shapes much faster than text. And if you do have to have text, you need to leverage the visual system by putting some structure into it. And if you put jargon in, now you're kicking in the need for more cognitive effort to interpret the text. So that if I've got this, well, even to an American audience, that doesn't make much sense, but if I format it the way Americans do telephone numbers, it's much easier. You might guess what that number is, but you'd be a lot faster at guessing if I did it like this. That's a credit card number. But the jargon problem certainly is something that you have to contend with. We as technologists tend to use jargon. Our users often don't understand it. So you could imagine a typical warning that somebody puts up about the OAuth token is not valid, it may be stale or corrupt. Well, users kind of just gloss over that. Cognitively speaking, they don't want to expend the effort to understand what you're trying to say there. I've kind of translated what they perceive out of that, and it comes out to something like this. It's gibberish because they don't really know what it's saying. The basic message they get from it is, whoops, sorry, I hit the button by accident there. The basic message they get from it is, do I want to do the thing that am I going to just go forward or not? They don't really get much out of it besides that. It's like, do you want to go ahead? Yes or no? And so understand when you put those kinds of warnings in front of users, you are taxing their cognitive systems to the point that you're risking that they just ignore anything that you have to say. So all of these things about how the eyes work and how the brain works yield something called design principles. They're really guidelines about what makes a design good or bad, not absolute rules for sure. But if you understand those design principles and respect them when you're creating user interfaces, then you'll avoid some mistakes that make interfaces harder to use. And they're based in how the visual system and the brain work, well, kind of whether you like it or not. So let's see an example of that. How many of you have seen a video with two teams passing basketballs, one dressed in white, one in black? Hands, please. How many? How many have not seen that video? Okay, that's about 2/3 of the crowd there. So I'm going to show that. It's only about 20 seconds. And those of you who have seen it, see, you have to be quiet. Yeah, you got the idea. So that we don't give away the lesson that people are going to learn from the video, because you have to focus. You have to really focus on the video to be able to fully understand what it's doing for you. So let me bring that up. Where is that? Here we are. Yeah. This is the basketball awareness test. Let's put that to full screen there. Come on. And let's play it.
This is an awareness test. How many passes does the team in white make?
Watch carefully now. Okay, how many passes did you see? 13? Most people see 13. There's a little bit of ambiguity, but most people do see that. But that's not really what the test is about. Did you notice anything unusual or unexpected in that video? Anyone? What did you see? Out loud, please. You saw somebody walking through, or I'm sorry, absolutely can't hear you. The monkey, or something. A monkey. Did anybody see anything look like a monkey? Did you guys see anything look like a monkey? No? Well, let's watch it again.
The answer is 13.
This time not worrying about the basketball.
But did you see the moonwalking bear?
Go!
Now, it is perfectly normal not to see that. I was at one training class in Idaho with 15 developers, and not a single one noticed the moonwalking bear. So what's going on there? Why does the visual system not see that? Well, what I did and what the video does is it gets you interested in something else. It primes you to look for the basketball, and it turns out that your visual system doesn't have a lot of bandwidth for seeing the entire visual field. That's just simply not the way it works. In fact, the area of high-resolution video is comparatively small. If I take this bottle cap right here, where'd that bottle cap go? This, and I hold that out at arm's length, that is roughly the amount of high resolution that we have in our visual field. And what our visual system is doing is constantly moving that around to what it has decided, that another part of the brain has decided is important. So when you give someone a task, that part of the retina, it's called the fovea. Some of you may have learned that term in biology. That part is constantly shifting around based on what the brain thinks is important right now. So when you set a task for someone, then you determine what their visual system is going to pay attention to, and it filters the rest out. It simply throws it away. And that's built into the visual system, and you really can't change it. Let's do another test, now that you even know that exists. So I'm going to show 3 slides, each for a few seconds, and they will have drawings of common tools that you might find around your house or workshop. The task I set for you in this case is, how many of these 3 slides contain a hammer? Now, I'm only going to show each slide about 3 seconds, but people generally don't have any trouble seeing the hammers. You ready? How many slides had a hammer? 2? Correct. The first and the third one, the middle one did not. But now if I come back at you with a different question and say, how many pairs of pliers did you see? Or scissors? Or wrenches? You have no clue, because that was not set. Your visual system basically filtered all that out as it searched for, I mean, your visual system kind of got close to that, or maybe even went right over it, but because it wasn't what you were interested in, it just got filtered out. Here, I'll show you the 3 slides again, and you can see that, yeah, there's wrenches and pliers, scissors, yeah, all over the place. And yet you didn't even notice them. So that is a design principle called inattentional blindness. It shows us that users are primed by goals. And that's not the only example of that kind of priming by goals that science has discovered. Usually when users go to a screen or a view or a page that you create, they go there for a reason. They have a goal. So one of the implications is, since the goal heavily influences how they see things, you should understand what the likely goal is when you create that view, because it's going to heavily influence how people perceive it. They will look for things related to the goal, and they'll filter everything else out and make the things related to a goal easy to find. That's good design. So as I said, inattentional blindness is an example of a design principle, that one that concerns the fact that we don't have a lot of high resolution. And again, let me emphasize, this is built in, so you can't really train around it. What people learn to do after a long time, if they've got a really crowded screen, is they train their eyes to kind of move to the things they care about, and they just filter the rest out. So if you're putting things on the screen that they don't care about, you're just making it more difficult for them to learn how to find the things they do need. That's one of the reasons why you don't want crowded screens. Another set of design principles are called Gestalt principles. You see them listed there: proximity, similarity, figure ground, continuity, and closure. And there are some others we don't have time for. And then that entire set of principles is based on our visual system, and I'm going to show you those in just a moment. There's also some design principles that are based on how the visual system coordinates with the rest of the brain. And those design principles are called archetypes and familiarity. Basically, sometimes experience influences what the visual system sees. You may not know this, but they've done studies of tribes that don't have buildings, hunter-gatherer tribes that don't have buildings. They have a very difficult time realizing if they see a door at an angle, they don't realize that it's a rectangle. They don't have the experience tied in for their visual systems to rapidly see that. So the experience ties into the visual system and helps it recognize things. As I said, inattentional blindness is one of them, and you can kind of see the idea there of the coin held at arm's length and filtering out anything that is not related to the goal that you see. So, for example, let me show you this screen right here. This is a kind of my spoofed up representation of a typical screen in a, let's say, not a 2005 app. Some of you probably have screens that look like that in your apps today. I see some nods that, yep, we've got some. Well, I left that screen up for about 4 seconds, and I didn't tell you anything, so you probably didn't notice this, but let me bring up my demonstration thing. So now let's get over here. So I have a little simulation that I wrote of the effect of the fovea being small. Did you notice, by the way, I left that up about 4 seconds. Did you notice who the screen was for, the demographic information in the upper left-hand side? Did you notice that? I mean, now that I've told you, of course, you go, yeah, that's Sherlock Holmes. But this simulation, I've put a little circle showing roughly the amount of high resolution that you actually see, and I've blurred out everything else. But I can drag this around, and I will bet not maybe one or two people in this entire crowd noticed that, in fact, once you start to wander over into the rest of the screen, the stuff there is absolute gibberish. It doesn't mean anything. Look at the labels there. Oh my goodness, they're cramming more stuff in here. What is a Fisher table or a Dingleplop or a raster possum? See, you don't realize all that stuff is over there even though you saw the screen because you didn't have any goal to find that out. You didn't even have a goal to find out who Sherlock Holmes was, so it was just clutter. It was no better than the shells on the beach to you. It was just a bunch of clutter. And that's one of the reasons you don't want to use crowded screens. If people don't have a clear goal and be able to find the information related to the goal, all that other stuff that's not relevant to their goal is just clutter. It just gets in their way. There it is. Yeah, and I've got a copy in the slides so you can kind of see. Be reminded if you get a copy of the slides. Sometimes the expectation of seeing something, that's called priming, and there are several forms of it. Inattentional blindness is one, but there are others. Let me show you a real case that I ran into. I was at actually an NDC conference in Minnesota a few years back, and I needed to go uphill to get to the conference center, and I was close to a parking garage that had an elevator, and I had walked down to get to the coffee shop, and I didn't want to walk back up 4 or 5 stories, so I went to find the elevator in the parking garage for the convention center to go up. And I want to go to find I found the elevator area, and I walked up to the elevator. Now, let me first ask you, from an expectation experience point of view, what do I expect an elevator button to look like? The thing to call the elevator, what shape do I expect that to be? It's almost always going to be round. That is an example of something known as an archetype. We expect elevator buttons to be round. They're not all round, but that's kind of our initial expectation. So I find the elevator area, and I walk up, and I see this. And I walked right up and punched that round thing. But what I got was a security guard on the speaker saying, "Yeah, what's your problem?" He sounded pretty bored too, because I think maybe a dozen times a day somebody comes and makes that mistake. Why did I make that mistake? Well, because I'm looking for a button that's round, I'm close to an elevator, and I'm thinking about something else. So we're going to talk about this a little bit more detail later. Distractions are just ubiquitous, and we don't need to create our interfaces that you have to be completely focused in order to use them. So when I looked at that, now we can kind of see it in detail, and there's a little bitty thing, emergency call box, which I filtered right out because that wasn't part of my goal, you see. And then if I get back far enough, I see that there is an elevator button to call it. It isn't very obvious. It doesn't stand out that much, not much contrast there. But I did manage to get on the elevator and get up to the next floor. So that kind of priming, and also a related thing, what's called framing, your experience ties into what you perceive in very dramatic ways you might not realize. They did an experiment with some people going through model kitchens, and they didn't tell them the real purpose of the experiment. There were like 7 or 8 of them. 2 of those kitchens did not have stoves in them. And they got at the end and they asked the people, "What did you think of the stove in all the kitchens?" People remembered seeing stoves that didn't exist because their experience with a kitchen is that it's got a stove in it. So their mind just filled that in. And people are also influenced by the concept of habituation, that ruts get worn in the mind, grooves get worn, and the visual system doesn't, it just kind of goes to sleep on some things. Let me show you, I've got my little, I've got my example of that. Let's see if I can bring that up. I've already got that there. No. So that's this. Let's go back over to that and put up a little screen that represents kind of workflow. I've got to shift it over there, don't I? So suppose we're working on some kind of a workflow and there's some stuff we've got to do for the first step. Actually, no, I've got to start this all over again because I was playing around with it and it obviously got some things incorrect. Am I going to have to start the whole program over? I am. It's maintaining some state that I didn't want it to maintain. It's just a demo program, so made a mistake there. All right, let's close you down. Come here. And restart the base program. Yeah, there it is. All right, sorry for that little delay there. Let's try this again. There we go. Now we've got it right. So we've got this little workflow thing, and we've completed the first step, and we go to the next step, and we got another step in the workflow. So we do whatever work we need to do there, and we click to the next workflow step, and we've got yet another step, and we complete that, and we get to the final thing, and we need to get done, and we press the button that's down in the same place that the next buttons were in all the three screens, and we just throw away all the work we just did. And you think, all right, that's stupid, Billy. Nobody would ever do that. Nobody would ever write software like that. Well, I give you American Airlines. I'm going to show you some sample screens that I took one day trying to book a flight. Now, they did eventually get rid of it, but this is the way it was when I captured these screens. So I have done 3 screens so far, picking my flights and taking off, And now I'm at the 4th screen, and I filled in some things at the top, and I think, okay, I'm done with the 4th one. All the other screens have had a continue button in the lower right. All 3. So I'm just, as usual, I'm not really paying that much attention, and I go down to the lower right and press that button that says Start Over, and throw away everything I'd done on 3 screens. Why did it appear that way? Well, it turned out that I had not yet filled in the credit card information, and so it can't continue. So some designer decided, well, it certainly looks nicer if the buttons are always right aligned, and of course we don't show buttons that can't be used right now, so we're going to get rid of the continue button. In fact, if you finish things up, it looks like this. But I had to go back and re-enter all 3 screens of data in order to get to this. Your visual system also takes context into account based on, what you see, what you kind of expect to see. If I tell you on the next screen that it's the map of a campus with some buildings and streets, then you see that, and okay, yeah, looks like a campus there. But if I tell you, well, actually, there's a word embedded in the buildings, did you feel your visual system shift as the context and expectation shifted? And those letters embedded in the buildings is an example of something called figure ground. Some of you, if you've had art classes, you may have seen that. The idea that the brain chooses what part of the visual field is important right now. and it interprets what it sees based on that. So in this particular case, this famous diagram can be interpreted two ways. And different people see different things. What did you see when you first looked at it? Two faces? Who saw something else? The outline of the vase? Yeah. So, and now that you know both of them are there, you can actually shift the perception to that. So that's an example of figure ground. And again, you say, well, what does that have to do with software? Well, here is from an application we wrote in 2008. We were working with some of the translucency and the things that we could do. So we made it so that if you're on a main screen, you're on a parent record screen, and you want to edit an address, okay, we're going to bring up the address, but we're also going to make the parent screen smaller and grayer, like this. What that does is then tip off the visual system to what is important, the figure. The figure changes from the main parent screen to the child screen. We're directing the user's attention to that. And then when we're done, we put it back the way it was. And we did that in 2008. About 2015 or 16, when HTML5 came out, we started seeing websites do that. This is a Twitter from a few years back. And it's got exactly the same effect, although I have to admit they did it better. But we should have made the gray darker. But that is a way of minimizing the effort people have in remembering where they are and what they should have to focus on. And especially if people get interrupted, coming back to something like this, the time to get back into the context of what it is you were trying to do, well, that's minimized because the context is clearly, I had the parent and I'm doing something with the child in front of it, with the entry window in front of it. Though that's an example of human limitations. And they're just, again, built into us. There's nothing we can do about it. We just don't see everything in the visual field. That's what inattentional blindness tells us. And now what we're discussing is this idea that attention is a scarce resource, very scarce. We just have a limited amount of it. Short-term memory has limited capacity. If I ask you to remember a three-digit number, you're going to do a lot better than if I ask you to remember an 8-digit number. That just is because of the limitations in short-term memory. So those limitations play into why the figure ground guiding attention is beneficial. It minimizes attention and minimizes short-term memory. You don't have to think, oh, what was I doing? When I come back from like the telephone that rang or something, and I come back to the screen, I don't have to think, wait a minute, what was I doing? The figure ground shows very easily and quickly what I was doing. So let's see this in more software terms that's more typical of the kind of stuff that you would write. So modern, I shouldn't say modern, that's not the right way to put it. Traditional business applications. They tend to have menus that more or less mirror the way the programmer thinks about it. You know, there's data and features. So there's file maintenance screens and there's screens that do things. And so the menus are kind of created around those features and that data. And that's not really the best way to do it, but that's the way a lot of systems are done. So that let's suppose that in this, and this is taken, by the way, from a real project I worked on. Let's suppose that the user, every morning when they come in, has to go through a series of tasks. They have to, this is for the cattle management people. They have to make sure that all the cattle are assigned to the right pens. They have to check to make sure that if there are any changes overnight in where the cattle were put, that's entered into the system. Because the cowboys don't do that. And then they have to check whether the feed costs have been allocated properly. And then they have to check, what is another thing? Whether or not they have to import some information from the veterinary system to see whether any cattle have died. And then they have to go do some billing for commodities. Okay, so there's several things they have to do. Now, it turns out that because of some of the file imports, and the later things they have to do it in order or the system will be messed up. And it's a lot of trouble to unwind the problems that they've done. Well, the software as written, this is spoofed. But this will be familiar, I think, for you in some of the applications you've seen, that to do those separate steps would be different places. So if we want to figure out where the cattle are or get them in the right place, then we go to this menu, location management, cattle pen transfers. And then we get ready to do the feed stuff. Well, that's a different menu, a different place. And then we want to do the vet import. Well, that's way over here, and import the vet charges. And then we want to do some stuff with commodities, and that's here. Now, notice that in order to carry out that workflow, because that's what it is, the user's now going to have to memorize a fair amount of stuff. They have to learn and understand, and they have to do it right. They have to do it in the right order, or they're in trouble. Well, that's really a problem for the users, because number one, when you do it that way, the user's attention is split. They have to use some of their attention just to navigate through the system, rather than you want as much of the attention as possible focused on the thing they're doing, the task at hand. So the attention was split, and the short-term memory is strained because the user is having to track, which tasks have I done? Which ones do I need to do? Instead, we should apply a design principle called recognition over recall. We don't want users to have to recall where a task is accomplished. Just give us one place where we can do all the tasks. And they shouldn't have to track in their minds whether the task has been completed. So what that means is, ideally, the users should just recognize the next thing they want to see, need to do off of a list, instead of using recall, having to know where in the menu option it is. And the interface should remember whether a task has been completed. So we might end up with something like this. We've got, okay, and we'll talk about the big thing on the left there. So we've got for each day, we put in the cattle movement. And notice that once we've completed that step, we get the check mark, and it goes gray. So that lowers the amount of effort we have to do to track what's been done and what has not. And there are some hints there about whether or not things need to be done. So the vet charges are coming up. That's pretty important because there's $1,500 worth of charges that need to be done. And the cattle movement might have a warning. Maybe those 2 unposted deaths mean that you've got something extra that you're going to have to do when you carry out that step. So you can walk down through the steps, and each step will take you to the appropriate screen to do things. And steps further down that weren't possible yet would also be disabled until the step they depend upon is done. So now we're guiding the user through the exact same workflow as before, but we are leveraging the recognition over recall so that the attention that they have to put into it and the amount of memorization they have to put into it is dramatically reduced. You can also be primed by past experience. I talked about the elevator button problem a few minutes ago. And experience, people can eventually learn complex stuff, even if it's incomprehensible when they first look at it. But if past experience is kind of commonly shared by people, then we kick into this idea of archetypes, things that we expect it to work that way. We expect elevator buttons to be round. And that's just one of many kinds of archetypes that we can put into software. This is an elevator panel. And when I first saw this, something struck me about it. I often ask crowds, audiences, when I have lots of time, what do you see about this that seems odd? And the usual developer answer is, there's no floor 13. Well, that's the analytical portion of your brain at work there, isn't it? But that's not what I noticed about this panel. What I noticed is that the paint on this placard is worn off. Why is the paint worn off? Well, because people are pressing that with their finger, thinking it's an elevator button. Why do they think it's an elevator button? It's round. So again, people don't scan around and look by default. Eventually, they pull back and kind of figure it out. And I think it's kind of funny because once people are doing that with the ground floor and spraining their finger, they've already been in this elevator once to go up to their room, and now they're going back down. And they're still getting it wrong. So that's an example of misuse of archetypes. And that's not just an isolated example. I also saw another elevator showing the same problems in Las Vegas. And I actually got on this elevator, and I was on floor 25. There was a guy standing by the panel, and he said, "What floor do you want to go?" I said, 25. He punched the button for 24. And, "Oh, I'm sorry, we'll have to stop." I said, "No, that's all right. Now we've got to go at 24 floors." So I gave him a lecture on elevator design, elevator panel design. And as always, I try to sort of communicate that over to software. This is a screen that I captured at a Marriott in Pennsylvania, where this is exactly what it looked like when I came up to it, and I wanted to get on the internet. So there we are, high-speed internet. Let me click that, because boy, that looks like a button, doesn't it? Well, it's not. When I pulled back, this is what the whole screen looks like. And the button does, in fact, look almost exactly like that header. Don't make your column headers look like buttons. That's a misuse of archetypes, and you're causing extra cognitive load on the user to have to sort that out. Experience can be leveraged in many ways. This is an app that we wrote for a propane management company. If you are in the industry of propane and fuel, then you know that propane is green, and you know the shape of the tank that it's in, and you know kerosene is red, and you know the shape of the tank that it's in, and so you don't have to be trained on that your visual system interprets that very quickly based on your experience, tying in your experience to your sensation. So let's go through a few more principles. I promised you the Gestalt principles. I like to show when I mess up, because that's kind of indicating that that lots of people would mess up. This was in a hotel that I was in. I'm coming in about 11:30 at night, very tired. I'm in room 207. I see the range, 201 to 223, and see the arrow right below it, and I take off in that direction. But that's not the right direction, as I found out pretty quickly. If you go back, you'll see this. Now, why did I make that mistake? Because the closest arrow to the range of my room is that one. And the eye automatically groups things that are close together. It assumes that things that are close together are related in some fashion. They should move those arrows down a little bit, and that sound would be a lot better. And Amazon made the same mistake on a shopping page, where I saw this very item here, this USB flash drive, and decided I wanted it. And I went, and where's my thing here? There it is. I went and did the checkbox down below it. You see the one? Can we see it over here? The one that's down below it. And in fact, you need the one that's above it. But that's further away. So I made that mistake. When I went to the shopping cart, the item was not there. The Gestalt principles are based on structure and relationships, and the human visual system's optimized for that. And there are stages of processing that indicate when the Gestalt principles kick in. They kick in unconsciously in about a quarter of a second, right after processing inside the retina. And then stage 3 is when some of that experience stuff gets applied that I talked about earlier. So we saw Gestalt proximity, and if you get things too close together, one of the implications is that you're more likely to make errors. There's the edit button, and it turns out that the edit button throws a lot of work away. And then the edit button for regular editing, and then this throws away your work to start over, and it's right next to the edit button. Silly. Also, the proximity principle sort of kicks in here too, because look at that. You see floor 4? It's got some braille on it. It's hard to see. Suppose I were a blind person and I found floor 4. Which button do I press? Well, that isn't obvious at all, is it? So proximity kind of works inside your mind this way, that Do you see rows or columns of stars in this grid? Rows, yeah. How about this one? You see columns, but that's the same size grid with the same number of stars. Do you see rows or columns now? Typically see rows. The color overrides the positioning. That's called Gestalt similarity, similarity by color. And you can also override with shape and size. Here, since I'm running out of time, I'll get to this. Typically, you'll see rows there too. All right, and we can leverage that in software in ways like this. If you put data on a timeline like this is customer interactions. Notice that things that happen close together in time become close together in distance. And the proximity principle kicks in and says, I bet those customer interactions are related. Maybe they did a service call and there's a payment for it or something. All right. I have a few more things that I'm not going to have time to get to, so I'll kind of go down to my last slide and take a question or two since we're at the end of the day, because my timing is out. It's done, isn't it? Yeah. I don't like going over. But I got into almost all the good stuff. I will mention very quickly, I've got some courses on that, on Pluralsight and LinkedIn, and the slides contain some QR codes for that, or you could just search for them. All right. Since we're at the end of the day, and I'm only 1 minute over, I can take a question or two, and then I'll let you go, because I know your neurotransmitters are depleted anyway. You're ready to get out of here. Right there.
How do you feel about color blindness in like grouping?
How do I feel about color blindness? Yes.
Red-green.
Certainly, red-green color blindness being the most common one. Typically, you don't want to rely too heavily upon color. Because of that, the first line of defense is to combine color with shape, so that they can group with shapes instead of the color. And you can still use the color for the 95% that don't have color blindness, but then you've got the shapes to help people. You can also check to see how the colors are perceived by colorblind people, and maybe tweak the colors a little bit there. Any more? No, I see some people on the edge of their seats, ready to rush out. But I will take one more if there are any. Shield the lights. Okay, I hope you've had some fun and found a few interesting things that you might apply to your work. I will post the slides on the conference site, and you're welcome to contact me about them if you like. I have fun doing this session because injecting science into the art of design and development, I think is a good thing for all of us. It helps us make stuff better for our users. Thank you very much, folks, and holler at me if you need to.